The Great Plains of India lie to the south of the Shivalik, separated by the Himalayan front fault. It is a transitional zone between the Himalaya of the north and the peninsular India of the south. In today's class, we will learn briefly about the plains, their features and their significance. The Great Plains are an aggradational plain formed by the alluvial deposits of the Indus, Ganga, Brahmaputra and their tributaries. The plain stretches for about 2,400 kilometers from west to east. It has varying width, 90 to 100 kilometers in Assam, 160 kilometers near the Rajmahal, the Jharkhand region, 200 kilometers in Bihar, 280 kilometers near Allahabad and 500 kilometers in Punjab. In general, the width of the plain increases from east to west. The Great Plains of India consist largely of alluvial deposits brought down by the rivers originating in the Himalayan and peninsular region. The exact depth of the alluvium has not yet been fully determined. According to the recent estimates, the average depth of alluvium in the southern side of the plain, which is the north region of Bundelkhand, varies between 1300 to 1400 meters, while towards the Shivaliks the depth of alluvium increases. The maximum depth of over 8,000 meters has been reached near Ambala, Yamunanagar and Jagadri, which is in Haryana. The Great Plains are remarkably homogeneous with little variation in relief features for hundreds of kilometers. The monotony of the physical landscape is broken at micro level by the river bluffs, bhars, leaves, dead arms of the river channels, the ravines and the cols. Changing river courses in the areas of frequent floods is a unique geomorphic process in the plains. The frequent floods, although a cause of immense damage to life and property, lay down fresh layer of silts in the floodplains each year, providing rich fertile soils. The puzzling questions are related to the enormous thickness of alluvium, nature of the depression, mode of its formation, subterranean rock beds and the underlying geological structure. Some of the important views about the origin of the northern plains of India have been presented briefly. Alluviation of the foredeep. According to Edward Suez, an eminent Austrian geologist, a foredeep was formed in the front of the high crust waves of the Himalaya as they were checked in their southernward advance by the more rigid landmass of the peninsula of India. This foredeep was like a large synclinorium, a large syncline with a number of small anticlines and synclines owing to the unevenness of its bottom. According to Suez, the bed of this foredeep had a gentle slope towards the north, whereas the peninsula side depicted a steep gradient. This bed rests on the basement of hard crystalline peninsular rocks through which the region is connected to the Himalayan and the peninsular blocks. The alluviation of this foredeep led to the formation of the Great Plains by the rivers, descending from the Himalayan region. One of the serious gaps in the Suez's theory is related to his inability to give suitable explanation to the uneven slope of the bed of the plain. Moreover, no conclusive evidence is available through which it could be inferred that there exists crustal connection between the Himalayan region and the peninsular block through the Great Plains. The next theory which tries to explain the Great Plains is the infilling of a rift valley. In the opinion of Sir G. Burrard, the northern plains of India are the result of infilling of a rift valley. Burrard opined that during the formation of the Himalaya, a rift valley was created between the two parallel faults, one along the southern boundary of the Shivaliks and the other along the northern boundary of the peninsula. This rift valley was filled up by the detritus brought down by the Himalayan rivers. In order to support his argument, Burrard has cited examples of the formation of similar rift valleys in the Himalaya and the Peninsular region, especially the Narmada and the Tapi rift valleys. This concept, however, does not find approval of the modern geologists. The main criticism raised against this concept is that nowhere in the world has such a giant rift valley with a length of 2,400 kilometers and a width of over 500 kilometers ever been formed by crustal downwrapping. Also, there is no geological evidence of the formation of such a rift valley in the northern part of the peninsular foreland. The uneven bottom and the northward slope of the bottom of the Great Plains of India have also not been explained by this concept. The next theory which tries to explain the plains formation is the recession of the sea. In the opinion of Blandford, during the Eocene period, peninsular India was joined together with Africa. During that period, there was one sea extending from Assam Valley to the Irrawaddy River in the east and another from Iran and Baluchistan to Ladakh in the west. During the last part of the Eocene period, arms of the Western Sea extended up to Punjab. Due to the rise of the Himalaya during the Miocene period, these seas started receding by gradual deposits of sediments from the Himalayan rivers. After a prolonged period of sedimentation and subsidence, these gulfs, the Gulf of Sindh in the west and the eastern Gulf up to the Shillong Plateau, were filled up, resulting in the formation of the northern plains of India. The evidences cited in favor of the recession of the sea include the occurrence of limestone rocks in Kumaon, Garhwal region of Uttarakhand, the presence of saline water lakes in Rajasthan, including the Sambar, Rajasmand, Pushkar, Panchpada, Nakki, Fateh Sagar, Debra, Balasmand, etc., and the joining of the islands of Gulf of Kutch with the mainland, the seaward extension of the Sundarban Delta, the emergence of new islands near Bangladesh coast, and the presence of marine fossils in the sediments of the northern plains of India. The theory, however, fails to give convincing arguments so far as the region of the central portion of the plain is concerned. The next theory, which tries to explain the formation, is the remnant of the Tethys. Some of the geologists and the geomorphologists opine that the Great Plains of India are a remnant of the Tethys Sea. According to them, after the upheaval of the Shivaliks, the remaining part of the Tethys was left as a large trough which was joined to the Bay of Bengal in the east and the Arabian Sea in the west. Rivers from the Himalaya deposited their load in the trough. Because the Himalaya were rising during that period, rivers experienced rejuvenation and greater quantity of eroded material which increased the thickness of alluviums. Due to the infilling of the central part of the trough, the seas located in the east and the west started receding and the Great Plains of India came into existence. The next theory are the recent views. According to the recent views, the northern plains of India represent a sag in the crust formed between the northward drifting of the Indian subcontinent and the comparatively soft sediments accumulated in the Tethyan basin when the latter were crumpled and lifted up into a mountain system. Subsequently, it was filled up by the river deposits. The Great Plains of India are a remarkably homogeneous surface with an imperceptible slope. In fact, they are a featureless alluvial fertile plains formed mostly by the depositional process of the Himalayan and the Vindhyan rivers. These rivers deposit enormous quantity of sediments along the foothills. Beyond the foothills, the rivers deposit the alluvium in their floodplains. The northern plains of India may be divided into the following sub-regions. The Bhabbar Plain. The location lies to the south of the Shivalik from west to east, Jammu division to Assam. Its width is greater in the western plains than in the eastern plains of Assam. Its width measures 8 to 15 kilometers. This region comprises of gravel and unasserted sediments deposited by the rivers descending from the Himalayan region and the Shivaliks. Due to high porosity, small streams, the Chos and the Raos, disappear in this region and only big rivers flow over the surface in this tract. And it's unsuitable for crop cultivation. Big trees with large roots thrive in this region. Inhabitants are largely cattle keeping Gujars. The next region is the Tarai tract. This lies south to the Bhabbar tract and it is 15 to 30 kilometers wide. It is wider in the eastern parts of the Great Plains in the Brahmaputra region due to high rainfall. It is a zone of excessive dampness, thick forests, rich wildlife and infested with mosquitoes. Once a marshy zone of jungle and wild grass along the southern edge of the Shivaliks, Tarai has been almost reclaimed for agriculture. In Uttarakhand, Uttar Pradesh, Haryana, Punjab and Jammu and Kashmir divisions, the Tarai forests have been cleared for cultivation of crops. The cultivated crops here include the sugarcane, rice, wheat, maize, oilseeds, pulses, fodder. Now the next feature is the Bhangar Plains. They represent the upland alluvial tracts of the Great Plains of India, formed by the older alluviums. The Bhangar formations were deposited during the Middle Pleistocene period and it lies above the flood limits of the rivers. Its soil is dark in color, rich in humus content and productive. It contains concretions and nodules of impure calcium carbonate or kankad. In relatively drier areas, the Bhangar also exhibits small tracts of saline and alkaline effortlessness known as the Re, Kallar or Thur. Bhangar is generally a well-drained and most productive land of the Great Plains of India. The Bhangar deposits have the fossils of elephants, horses, man, rhinoceros, hippopotamus, etc. The Khadar Plains. The new alluvium tracts along the courses of the rivers are known as the Khadar or Beth lands. Tracts are enriched by fresh deposits of silt every year during the rainy season. Khadar land consists of sand, silt, clay and mud. Post-independence, this region has been brought under cultivation and devoted to sugarcane, rice, wheat, maize, oilseeds, legumes and fodder crops. The Khadar deposits have the fossils of living species like man, deer, oxen, buffaloes, elephants, rhinos, etc. Next feature is the Delta Plains. The Deltaic Plain is an extension of the Khadar land. It covers about 1.9 lakh square kilometers of area in the lower reaches of the Ganga River. It is an area of deposition as the river flows in this tract sluggishly. The Deltaic Plain consists mainly of old mud, new mud and marsh. In the Delta region, the uplands are called chars, while marshy areas are known as bills. The delta of the Ganga, being an active one, is extending towards the Bay of Bengal. Now let's look at them. On the basis of the geoclimatic and topographical characteristics, the northern plains of India may be divided into the following four meso-regions: the plains of Rajasthan, the Punjab-Haryana plains, the Ganga plains and the Brahmaputra plains. Now let's look at the features individually. The plains of Rajasthan. They lie to the west of the Aravalis and include the Marusthali and the Bagar of Rajasthan. The Rajasthan plains cover a total area of about 1,75,000 square kilometers. This plain has a general slope from northeast to southwest. In the lower reaches of the Luni River in the Gujarat region, this plain is only 20 meters above the sea level. A substantial part of this plain has been formed by the recession of the sea, as is evidenced by the presence of the saltwater lakes like the Sambar, Degana, Dindwana, Kanchman. The Sambar lake, occupying an area of about 300 square kilometers during the rainy season, lies about 65 kilometers to the northwest of the Jaipur city. During the Permo-Carboniferous period, the greater part of the Rajasthan plain was under the sea. It has several dry beds of rivers like Saraswati and Drisdavati, which indicate that the area earlier was fertile. At present, Luni is the only flowing river which recedes the Arabian Sea through the marshes of Rann of Kutch. Its water is sweet in the upper reaches but turns brackish in the lower parts. North of the Luni, there is a large area of inland drainage. At present, the greater part of the Rajasthan plains are a desert covered with longitudinal and transverse sand dunes and barchans. A large number of playa lakes occur in the basins. In the southwestern parts of Rajasthan plain, there are the alluvial tracts known as Roi, the fertile plains. In the northeastern part, they consist of dry beds of ghaggar known as the Ghaggar Plains. The next part, the Punjab-Haryana Plains. Stretching over an area of about 650 kilometers from northeast to southwest and 300 kilometers from west to east, the Punjab-Haryana Plain is an aggradational plain deposited by Satluj, Beas and the Ravi rivers. The height of the plains varies from 300 meters in the north near Jammu and Kathua to 200 meters in the southeast. In the east, the Delhi Ridge separates it from the Gangetic Plain. The general direction of slope is from northeast to southwest and south. The main topographical features of the Punjab-Haryana plains are bluffs, locally called as dhaya, as high as 3 meters or more, and the khadar belts known as bait. The undulating topography south of the Shivaliks is adversely affected by erosion caused by the seasonal streams locally called as chos. The southwestern parts, especially Hisar district, is sandy, characterized by shifting sand dunes. Satluj, Beas and Ravi are the only perennial rivers. Between the Satluj and the Yamuna, the Ghaggar, which is the ancient Saraswati, is a seasonal stream which passes through the Ambala Cant. Its course is about 10 km wide and contains water only during the rainy season. The Punjab-Haryana plains may be divided into the Bari Doab between the Beas and the Ravi, the Bist Doab between Beas and Satluj, the Malwa plain, the central part of the region, and the Haryana Bhiwandi Bagar in the southern parts of the region and the southeast parts of the region. Now the next feature, the Ganga Plains. The Ganga Plains lie between Yamuna catchment in the west to the Bangladesh border in the east. It's about 1400 kilometers from west to east and has an average width of 300 kilometers from north to south. The general gradient of the plain is about 15 centimeters per kilometer from northwest to southeast. The maximum height of this plain is found to the north of Sarhanpur, 276 meters, followed by Roorkee, 274 meters, Agra, 169 meters, Kanpur, 125 meters, Allahabad, Patna, Kolkata and Sagar Island only 3 meters above the sea level. The main topographical variations in the plains include the Bhabbar, Tarai, Bhangar, Khadar, river bluffs, which are levees, abandoned courses, khols, dead channels, bills, tals and badlands. The Ganga plains can be subdivided into the following subregions. The Upper Ganga Plain. The Upper Ganga Plain includes the Ganga Yamuna Doab, Rohilkhand division and parts of the Agra division. The catchment area of Yamuna river makes its western boundary. Shivaliks in the north, 125 meter contour in the south. The elevation of the Upper Ganga Plain varies between 100 meters to about 300 meters. In addition to Ganga and Yamuna, it is traversed by the Kali and the Sharda rivers. A unique feature of the Upper Ganga Plain is the presence of bhad, undulating aeolian sandy deposits. Now the next region that it can be divided into is the Middle Ganga Plain. Sprawling over an area of about 1,44,400 square kilometers, the Middle Ganga Plain includes central and eastern UP and the Bihar plains up to Muzaffarpur and Patna. In the north, it is bounded by Shivaliks along the Indo-Nepal border. It has thick alluvial deposits with less Kankar formation. The region is homogeneous and featureless, where monotony is broken by river levees, bluffs, oxbow lakes, dhus, tals, jala and shores. Being a low gradient plain, the rivers often change their courses in this region. Gandak and Kosi are the main left-hand tributaries, while Son is an important right-hand tributary of the Ganga in the Middle Ganga Plain. The next feature is the Lower Ganga Plain, area of about 80,970 square kilometers. The Lower Ganga Plain extends from Patna in the west, the foot of the Darjeeling Himalaya in the north, to the Bay of Bengal in the south. It is bordered by Assam and Bangladesh in the east and the Chota Nagpur Plateau in the west. In the lower part of the Lower Ganga Plain is the Sundarban Delta. The plain has a monotonous surface. The eastern part of the plain is drained by the Teesta, Jhaldakia, Sankosh joining the Brahmaputra, and the western part by Mahananda, Ajay and Damodar. In the extreme southwest, Kasai and Subarnarekha are the main rivers. The general slope of the plain is towards south and southeast. The lower Ganga plain has been formed by the down-wrapping of a part of the peninsular India between Rajmahal Hills and the Meghalaya Plateau and subsequent sedimentation by Ganga and the Brahmaputra rivers. The plain has a monotonous surface dissected frequently by the channels of the main streams and their tributaries. Rud Plain. Lying to the east of the Chota Nagpur Plateau, it is a part of the lower Gangetic Plains. Drained by the Damodar and Subarnarekha, it is covered by the lateric alluvium soils. Soil erosion is the main problem of the Rud Plain. Rice, maize and pulses are the main crops of the Rud Plain. Sundarbans. The largest mangrove swamp in the world, the Sundarbans or the beautiful forest, gets its name from the Sundari tree, which grows well in the marshland. It is home to the royal tiger and crocodiles. The Brahmaputra Plains, stretching over an area of about 56,275 square kilometers, it is the eastern part of the Great Plains of India. It is about 720 kilometers long and about 80 kilometers wide. The region is surrounded by high mountains on all sides except on the west. It is a depositional plain. The general altitude of the Brahmaputra plain varies between 130 meters in the east to only 30 meters in the west. The Assam Valley is characterized by a steep slope along its northern margin, but the southern side has a gradual fall from the Meghalaya plateau. The whole length of the plain is traversed by the Brahmaputra. Due to low gradient, the Brahmaputra is a highly braided river having numerous islands. Majuli, which has an area of 930 square kilometers, is the largest river island of India and the second largest in the world after the Marajo island of Amazon river. The valley of Brahmaputra also has a number of isolated hillocks on both flanks of the Brahmaputra river. It is one of the most productive plains of India in which rice and jute are the main crops. There is a marked difference between the physiography of north and the south banks of the Brahmaputra river. The northern tributaries descending from the Arunachal and Assam hills form a series of alluvial fans which coalesce and obstruct the courses of the tributaries, forcing them to form meanders and adopt parallel courses along the main stream of Brahmaputra. Consequently, there are numerous levees along the north bank. This has led to the formation of the bills, oxbow lakes, marshy tracts and tarai lands with dense forest cover. The southern bank of Brahmaputra is less uneven and less wide. Moreover, the tributaries in the southern part are considerably larger. Here, Dhansiri and Kapili, through their headward erosion, have almost isolated the Mikir and the Renegma hills from the Meghalaya plateau. The valley of Assam may be divided into the upper Assam and the lower Assam. These are demarcated along the 94° east longitude. The upper Assam valley includes the districts of Lakhimpur, Dibrugarh, Jorhat and Sibsagar and the Tezpur Tehsil of the Darrang district. It is a monotonous plain except for the low hill ranges along the southern and the southeastern border. Lower Assam Valley consists of the Nagaon, Dhubri, Golpara, Barbata, Kamrup, Nalbari, Kokrajhar and the parts of Darrang district. This region does not possess monotonous physiographic characteristics since its landscape is interspersed with the spurs of Meghalaya plateau. Here, the right bank tributaries form a terracelous pattern of drainage while the left bank tributaries exhibit the dendritic pattern. Swarms in the marshes is numerous in the northern region of the lower Brahmaputra valley. The next feature, the Brahmaputra. It is one of the great rivers in the world flowing eastward to the north of the Himalaya in the Tibet. It turns out sharply south and passes through Assam before entering Bangladesh. The river valley has fertile alluvial plain which is conducive to growing rice and jute. It is also famous for its tea and the two national parks at Kaziranga and Manas. The Great Plains of India have been the repository of the Indian culture. This is covered with one of the most productive soils of the world. Its soils have the capacity to grow any crop of the tropical and temperate regions. The soils of the plains are agriculturally most fertile. They are being devoted to the cereal and the non-cereal crops. The plains are often termed as the granary of India.